Good afternoon. Hey, Miss Townsend.
He'll be here in just a second.
All right, good. I was a little worried.
You know that
when he's here, so.
that little last minute, I heard the door. Last minute, have to go to the bathroom.
Okay.
I'm here. I'm sorry.
You're good. You're good. So do we have any crazy testing dates in Mogollon coming up that's going to affect my trig class or no?
I don't think so. I've been doing what they've been doing is taking Wednesdays and having them come in with me and do AZ merit testing on those days.
Oh, good. Well,
So you shouldn't have had any interruptions from that this year.
Well, not from Mogollon.
From me, yes.
Not from you. So, okay, I appreciate that.
So are you
All right.
thinking the 8th and 9th for finals for both math classes? Or?
Yeah, what was it we had on the 10th?
I think that is it 10th of Friday?
Or no?
Yeah.
No, yeah. So
Oh.
the 8th and the 9th. But somebody was saying something about the 9th. Was it
No,
one
the
of you guys?
graduation. It was Weston.
Yeah,
Oh,
that's
that's
me.
right. Yeah. So so I'm gonna check on that. So Weston might take both parts on the 8th, but I think for everybody else, I think the 8th and the 9th is what I'm looking at now.
Okay, no problem. I looked at my calendar. It looks pretty clear. So.
All right. Awesome.
All right. I'll let you guys get to it.
All right. Thank you.
You're welcome.
All right. So I don't know. Oh, there's Jada. All right. So anything exciting going on today? For anybody? No? Well, well, I am getting actually pretty excited because we're gonna be by this time next week we'll be done with chapter 10. So I'm pretty excited about that. And anyway, we're in good shape to finish and have the final. So the main thing that I guess I want to say before we get started, especially with these sections where they're like a day or less of material to go through, these quizzes are going to pile up. Don't let them snowball on you. You need to try to keep up. They're not going to take you a whole lot of time, but don't I mean, if every day I'm going to be opening up another quiz or two, you need to be taking them. Okay, so just kind of keep on that. All right, well, let's go ahead and get started here. We're on 10.7, which is called the Power Series. And anyway, it was kind of funny that Professor Blake, when I told him that I was going to be out, he wanted to, for the 2 days, he wanted to teach this 10.7 and 10.8. I told him it was fine, and he decided to kind of stay with the order. Okay, but okay, so you've all got the guided notes for 10.7. Everybody got that? Yeah? Okay. All right. So basically, we're talking about here another kind of series. So instead of just having like the summation sign like we've had this whole chapter, this is going to be what's called a power series, is what we're going to look at. And then tomorrow, we're going to look at specific kinds of power series. So really the last 3 or 4 sections are going to be on this type of series. Okay. And then I did the series test. I think I told you that there was a handout on kind of a review of all of the integral test and the ratio test, limit test. I put that, so that's near the top of chapter 10 on the Moodle. You can kind of print that out and it'll have it's a nice little summary of it. I didn't create it, but it's pretty good. Okay, so back to it. So a power series. So a power series about x equals 0 is a series of the form. Okay, so you still have a summation. The c sub n's are just constants. So you have a constant in each term, and then you have a power of x. So you could even think of this one as x to the 0, x to the first, x squared, and so that's a power series. So a constant times x. Okay. And so then you just, it keeps on going forever. Okay. Let's see. Okay. So now, really, you have to know where the center of the series is, or it'll say at x equals something. So these first ones that we have are going to be centered about x equals 0. And so that means each term will have like x minus 0 to some power, which is the same thing as like x cubed. But if the series is centered about x equals 3, then it would be x minus 3 to whatever power. Okay? So each of these little terms is going to be affected by what the center of the series is. Okay? All right. So if we have all the coefficients to be 1 in that formula I gave, then this becomes a geometric power series. So we have 1 x to the 0 plus x to the first plus x to the second plus and so on. So it's a geometric series and you're multiplying by x each time. Okay. All right. So, but still, it's x minus 0. There's just x in there. Okay. Okay, so this says represent 2 divided by x as a power series about x equals 0. Okay, now let's see here. This is actually not. So these are the coefficients. So 2 over 1 is 2. 2 over 2 is 1. 2 over 3, 2 over 4 is 1/2. So these will be your coefficients right here. Okay? So these are the coefficients. So just see if you can do that. See if you can write the power series. Okay, So this is what, I mean, you could have as your next step. See, the coefficients, 2 over 1, 1, 2 over 3, and 1/2. Then in place of the n, or the x, you're going to have x minus 0 to the 0, x minus 0 to the first, x minus 0 squared, x minus 0 cubed. Then when you clean it up, then see, x minus 0 is just x, but anything to the 0 power is 1. So the first term you're going to get is 2 over 1, which is just 2. All right, and then you're going to have 1 over x, 2 over 3x squared, 1 over 2x cubed, plus dot, dot, dot. All right, any questions on that? So this is centered about x equals 0. So if you centered it about a different number, like say 5, then all of these denominators would be, where there's a 0, you'd have a 5. Okay? So it says a power series about x equals a is a series of the form. Okay, so you still have your coefficients in front, the c sub n's. So the coefficients could be whatever pattern. All right, but now each term is going to have x minus a to the nth power. So the first one, I even, just so that it follows the pattern, I put x minus a to the 0, which that's going to go away. And then x minus a to the first, x minus a to the second, x minus a to the third, and so on. All right, so in this formula, so example 2, so we have a power series where the coefficients come from negative 1/2 to the n. Okay, so negative 1/2 to the 0, anything to the 0 is 1. And then just looking at the coefficients, negative 1/2 to the first is negative 1/2. Negative 1/2 squared is 1/4, and so on. So the coefficients come from this part. All right, then the power series, this is centered at 2. And so you start off with x minus 2 to the 0, x minus 2 to the first, x minus 2 to the second, x minus 2 to the third, and so on. Okay? So now here, because we're multiplying each term, everything is raised to the n. So this is actually a geometric sequence. But the r is a little more complicated than ones that we've dealt with. The r is not like 3 or 1/2 or whatever. The r is negative 1/2 times x minus 2. Because each time, see, as n goes up, you're multiplying by a negative 1/2, and you're multiplying by another x minus 2. So that's the r. It's what you're multiplying by each time. Okay? So in the... so a little bit in this section, but also in the next section, we can talk about where this power series converges. Now, it might seem weird because it's, or does it converge? Well, it converges where all of this is between negative 1 and 1, because that's the definition of converging geometric series, when the r value is between negative 1 and 1. So what we do is we take this and say, okay, you can write it as, where is the absolute value? Less than 1 Or I actually, well, okay, so it's a little bit easier then if we, because it's absolute value, you can get rid of that negative inside. And then you can solve it. -1 is less than x minus 2 over 2 is less than 1. Multiply everything by 2. And then add 2. So that means that this series converges for all x's between 0 and 4. Because then that gives us the r value between -1 and 1. Now, two other terms that are going to be, this is just vocabulary. So the center of convergence would be, what numbers would be in the middle between 0 and 4? 2. So 2 is called the center of convergence. And then the radius of convergence, I mean, think of like a circle. The radius is the distance from the center to the circle. Well, the center we just said was 2, so the distance between 2 and 4 is also 2. So the radius of convergence here is 2. Okay? So it's just some kind of terminology there. Okay? All right. Let's have you... Okay. So now what we're going to do is have you represent, this is the same one that we did in practice 1, only now I'm changing the center to 1 instead of 0. So write the power series. All right, let's take a look. Okay, so we have the same coefficients that we did before. Okay, but now instead of just x in the denominator or x minus 0, it's x minus 1 to the 0, x minus 1 to the first, x minus 1 to the second, x minus 1 to the third. And so if we clean that up, so anything to the 0 power is 1, so the first term is just going to be 2, plus 1 over x minus 1, plus 2 over 3 times x minus 1 squared, plus 1 over 2 x minus 1 cubed, plus ... That actually goes on forever. Okay? Do we all get that? Any questions? Okay. All right, very good. Okay, so the A equals 1, that's the center of the series is also going to be the center of convergence. So that's another way to look at it. So we don't even, if it and this one, it's also going to be geometric. Okay. Let's see. So this is, let's see. Let's just do it for fun. Let's see if we can find the center of convergence, okay, and the radius of convergence. Okay, so this time is we're multiplying by 1 over x minus 1. Okay, let's see. So what we can say then is this converges for if the absolute value of 1 over x minus 1 is less than 1. Okay? So then to solve that, you would say, okay, negative 1 is less than 1 over x minus 1 is less than 1. Let's see. Well, okay, so let's see. Probably the way to solve that would be to invert the fraction. Okay, so actually, let's do that. Let me back this up here. We actually want to invert it. See, if I invert this fraction while it's still an absolute value, then I don't have to worry about if I'm multiplying or dividing by a negative. So if I invert this fraction, and say the absolute value of x minus 1 over 1, okay, since this is positive, it's is less than 1. I don't have to change that sign. So then I can say negative 1 is less than x minus 1 is less than 1. And then to solve for x in the middle, I add 1. So that would give me, here, just adding 1 to each part. I get 0 is less than x is less than 2. Okay, so then that's, so it converges for those values of x. So it converges for those. So the center of convergence, so the center of this should always be the same as the A that you're given, 1. And so 1 is exactly in the middle. So the center of convergence is at x equals 1. Now, the radius of convergence would be what? What's the radius of convergence for this one?
It'd just be 1.
It would just be 1. So it's the distance between the center and then either one of these outside numbers. Okay? So, let's see, okay, so yeah, they do use the term interval. So this from 0 to 2. So let's see. So 0 to 2 is the interval of convergence. And then x equals 1 is the center of convergence. And then 1 is the radius of convergence. Okay. Okay. Any questions on that? Okay. All right, we can test the power series for convergence using the ratio test. So, especially if it's not geometric, then the ratio test is usually the one that works best for these because you're dealing with exponents. So you can do the x to the n plus 1 over x to the n. So you can do the ratio test. If it is geometric, then what we just did is the easiest way to do it. But if it's not geometric, then the ratio test is the way to go. All right, so, okay, so let's say I want to test this. Here, let's actually... Okay, so I'm going to test this series for convergence. All right, so now what we usually will do when you see an alternator is first see if it's absolutely convergent. So cover this up and then just try that. And so this is a good one to do the ratio test. So if you remember, the ratio test is where you do the n plus 1 term over the nth term. So this right here goes in the denominator and then replacing n with n plus 1 in the numerator. So that's the ratio test right there. Okay? All right, so then we invert and multiply the denominator. So we're going to get the limit as n approaches infinity of x to the n plus 1 over n plus 1 divided by, and you flip this and you get n over x to the n. All right, so x to the n plus 1 over x to the n, that will cancel to what? What will that simplify to? X to the n plus 1 divided by x to the n.
Would it just be 1?
It would be x to the 1 or just x, okay? Because you would subtract the exponent. So n plus 1 minus n is just 1, but it's x to the 1. So you're going to get x times n over n plus 1. Now, when you go to take this limit as n approaches infinity, you're going to get infinity over infinity. Okay? But see, this is one where you can compare the powers, and since you could use L'Hopital's rule on this part, or you could just say, you know what, comparing the powers, they tie, so the limit's going to be 1 over 1. Okay? So this is going to go to 1, so you have 1 times x, or x. Okay? So so for the ratio test, what do you not want the answer to be? Or when does the ratio test converge?
If rho, is that how you say it, rho?
Yeah.
Is less than 1?
Is less than 1, then it converges. Okay? So if then what you want then, so if this part gets you 1, then this is going to converge if x is less than 1. So this converges if x is less than 1. Because then that will give you a rho less than 1. And then by the ratio test, it would converge. Okay? All right, so let's see if you can do example 3a. I practice 3a. This is example 3a. So see if you can do practice 3a on the sheet. All right, anybody think they've got it? Okay, so let's look at, once again, here we just sort of ignore the alternator and try to see if it converges absolutely. So using the ratio test, you get, so when I replace n with n plus 1, I get 2 to the n plus 1 minus 1. So that's going to give me 2n plus 2 minus 1, or 2n plus 1. So I get x to the 2n plus 1 over 2n plus 1 over x to the 2n minus 1 over 2n minus 1. And then I invert and multiply. All right, so any questions on the algebra so far? Okay, so what about this cancellation here? What x to the 2n plus 1 divided by x to the 2n minus 1, what will that simplify to?
Would it be x squared?
X squared. Because the two n's cancel, and then you have 1 minus negative 1. And so you're going to get x squared over 2n minus 1 over 2n plus 1. All right? So any questions so far? Okay, so now let's look at the limit. As n approaches infinity, then again, we're going to have infinity over infinity, but you can compare the powers. They tie. So this limit is going to go to 2 over 2 or 1. So 1 times x squared, this is just going to be x squared. So then, for what values does this converge? What do we want x squared to be in the ratio test for it to converge? So in the ratio test, what do we want rho to be to converge?
Less than 1.
So less than 1. So then we're going to say that this series converges if x squared is less than 1. So that's if rho is less than 1. So in other words, we got our rho is x squared. So if x squared is less than 1, then the series converges. That make sense? Okay. Well, let's do another one here. So now I want you to do practice 3B. Basically, the reason why I'm throwing that in there is because it has a factorial. And I feel like we need more practice with factorials and doing the algebra with the factorials. So do the ratio test again with practice 3B. Okay, so using the ratio test, this is what we get. This is the limit that we're trying to do. All right, so Tobias, what does n plus 1 factorial over n factorial simplify to?
Okay, so you can like change the n plus 1 factorial to n plus 1 and then n factorial. So then the
Yes.
two n factorials will cancel out. So it should just be n plus 1 over 1.
Correct. N plus 1 over 1. Yep. All right, Jada, what does x to the n plus 1 over x to the n simplify to?
Would it be x squared or just x?
Just x. Because see, when you subtract the exponents, n plus 1 minus n would just be 1. So x to the first. Okay? So you end up with n plus 1 times x. Well, as n approaches infinity, infinity plus 1 is going to be infinity times anything is infinity except what's the one thing that could, if you multiply by infinity, that you don't get infinity? There's only one number that would trump infinity when you multiply them. What would that be?
0?
0. Because see, even if you multiply infinity by 0.1, it's still going to be infinity. All right? But if you multiply it by 0, that's the one thing that would mess it up. So this is going to go to infinity unless x is 0. Okay? Now, what happens if you get a row of infinity when you're doing the ratio test?
It diverges.
Okay? So then we would say this series diverges for all x except x equals 0. Because then we would get a row of 0, which is less than 1. Okay? And then so it would converge only for that one value of x. Okay, so this is the last little bit. Couple of slides with some notes on it. So if the power series converges for all x's except 0, then it converges absolutely for all x less than c. So if it converges for one value of c, it's going to converge for all values less than that. Okay, if it diverges for x equals some number, then it diverges for all numbers bigger than that. So if it diverges when x is 5, then it's going to diverge for all x is greater than 5. It's kind of what this is saying. Okay? And finally, the last slide here says that if you have two series that converge absolutely, if you multiply them together, it's going to converge out. They're going to converge absolutely. So I sort of wrote all of this in English. The product of two absolutely converging series converges absolutely. All right. Okay, and that kind of works the way you think it is, so I'm not going to worry about that one. But Okay, so we finished 10.7. Tomorrow we'll start on 10.8. Please come with questions if you have any or any problems that you'd like me to work or that you want to discuss. Otherwise, we'll start on 10.8 tomorrow. Okay? All right. So now, Tobias, you don't have a game tomorrow, right? I can't remember if you told me.
No, I don't have any games this week. I only have one game next week, and that's against Joe City.
Okay. When is that? You know what day that is?
Not sure. I think it's Tuesday or Wednesday.
Okay. If you would, just check and let me know tomorrow. Okay?
Okay.
All right. Well, you guys have a great day. We'll see you tomorrow.